application systems are commonly used in manufacturing, but even these systems face challenges in ensuring consistent and precise application. 18. 3D printed glues can be designed for particular materials and performance requirements, allowing for highly specialized adhesives that would be difficult or impossible to create using traditional methods. Additionally, 3D printing technology is also being used to print products that require specific adhesive formulations, such as flexible electronics or wearable medical devices. Nanotechnology. Nanotechnology is being applied to create adhesives with improved properties. Nanofillers such as carbon nanotubes or silica particles can be added to glues to enhance their strength, flexibility, or conductivity. Nanocoatings applied to adhesive surfaces can also improve their resistance to corrosion or wear and tear, making them ideal for high-performance applications like aerospace or automotive parts. Microencapsulation. Microencapsulation is a technique where the adhesive is sealed within small capsules that only release their bonding properties when triggered by heat, pressure, or moisture. This technology allows for self-healing adhesives, which can repair themselves when exposed to damage or stress. Smart manufacturing. The adhesive industry is also benefiting from Industry 4.0 technologies, including the use of sensors, real-time data collection, and AI to improve manufacturing processes. Smart systems can detect variations in raw material quality, monitor production efficiency, and adjust conditions on the fly to ensure the highest quality adhesive products. Hot melt adhesive systems. These systems are used in industries like the process in a glue factory typically involves several stages to transform raw materials into various types of adhesives. Here's an overview of how glue is commonly produced. Raw material selection. Glue can be made from various sources, including natural materials like animal bones, hides, or plant-based substances such as starch or cellulose, or from synthetic materials like synthetic resins or polymers. Preparation of base materials. If the glue is animal-based like hide glue, animal collagen from bones or hides is heated to break down the protein and create a gelatinous substance. For plant-based glues, starches or other plant derivatives are processed into a slurry. For synthetic glues, petroleum-based products or chemical compounds are mixed. Cooking and melting. The raw materials are heated and combined in large industrial vats. Animal-based glues, for instance, require boiling to break down collagen. In the case of synthetic glues, the raw chemicals are mixed and heated to the appropriate consistency. Cooling and solidifying. Once the glue is cooked and mixed, it is allowed to cool and solidify into its final form, which can range from liquid adhesives to solid sticks or sheets, depending on the intended use. Packaging. The final product is packaged into containers, whether it be in tubes, bottles, or bulk quantities, depending on the manufacturer's target market, for example, industrial, craft, or household use. Quality control. Throughout the process, the glue undergoes rigorous quality control tests to ensure it meets the required strength, bonding capability, drying time, and resistance to various conditions. Types of glue production. Animal-based glues. These are derived from collagen-rich materials, such as bones, skin, and cartilage of animals, primarily cows, pigs, and horses. The glue production process for these involves extracting the collagen by boiling the raw materials in water, breaking them down into gelatinous compounds that, when cooled, form a sticky substance. Hide glue. One of the oldest types of glue, used in woodworking and musical instrument making. Fish glue. Made from fish skin and bones, used for fine art and delicate repairs. Plant-based glues. These come from starches, resins, and natural gums. These glues are often used for paper, food packaging, and general-purpose adhesives. Starch-based glue, derived from corn, wheat, or potatoes. It's common in wallpaper, pasting, and school glues. Gum-based glue, made from natural tree resins, often used in the production of adhesives for labels, envelopes, and some medical applications. Synthetic glues. These are made from synthetic polymers and resins, and they dominate the adhesive industry today due to their versatility and high performance. Epoxy, a highly durable glue used in construction and automotive industries. Polyurethane, used for both bonding and sealing in industrial and DIY projects. Superglue cyanoacrylate, fast-drying and very strong, used for household repairs and medical uses. PVA polyvinyl acetate, commonly used for woodwork and crafting. 2. Pre-processing raw materials. Animal collagen processing. In the case of animal-based glues, raw animal hides or bones are first cleaned and stripped of fats. These materials are then boiled in water or acid to extract the collagen, which is the essential protein for glue production. After boiling, the liquid gelatin is strained, and then the water is evaporated to create a concentrated, sticky substance. Plant-based resins. 4. Plant-based adhesives. Resins like gum arabic, gar gum, or starch are often processed through grinding and heating to break down complex molecules into simpler sugars or gums that are more adhesive. Synthetic resins. Chemical resins or synthetic polymers, such as epoxy or cyanoacrylate, are often created from petrochemical byproducts. They are polymerized and processed under heat and pressure to achieve the desired chemical structure. 3. Polymerization. For synthetic glues, polymers are long chains of molecules that give the glue its strength and flexibility. Depending on the desired properties, the process of polymerization is fine-tuned. Thermosetting resins. These are resins that, once heated and set, cannot be they are ideal for high-strength adhesives like epoxy. Thermoplastic resins. These resins can be remelted after hardening, which makes them useful for things like hot melt adhesives, used in packaging and crafts. 4. Mixing and blending. After the base material, whether animal, plant, or synthetic, has been processed, it is mixed with other ingredients. Plasticizers are added to improve flexibility. Stabilizers prevent degradation over time. Fillers like chalk or clay can adjust viscosity or add bulk. Solvents may be used to adjust the consistency, particularly for glues that need to be applied in liquid form, such as in spray adhesives or glue in a liquid bottle. 5. Refinement and filtration. Some glues undergo a refinement or filtration process to ensure the absence of impurities that could affect their bonding strength. For animal-based glues, impurities like fatty residues are removed. For synthetic glues, excess chemicals or byproducts are filtered out to improve purity. 6. Curing and drying. Air-dried glues. Some glues, for example, PVA, or animal-based glues, are designed to air-dry. The solvents or water evaporate naturally over time, leaving behind a strong bond. Heat-cured adhesives. Epoxy and some other industrial adhesives need heat to cure. After application, the glue is exposed to heat in an oven or other controlled environment to harden and form a strong bond. 7. Final testing and quality control. Viscosity testing. The glue is checked for its ability to flow easily and uniformly during application. Strength testing. The adhesive's bonding strength is tested by applying it to different materials and measuring how well it holds up under stress or pressure. Drying speed. The time it takes for the glue to dry or set is also tested to ensure it matches the required specifications. Adhesion tests. Samples are tested on different surfaces, such as wood, metal, and plastic, to ensure the glue adheres properly in various applications. 8. Packaging and distribution. Once the glue has passed quality tests, it is packaged into containers. This can range from small tubes and bottles for household. Use 2 large drums or industrial-sized containers for bulk manufacturing. Automated systems fill, seal, and label the packages. The packaging material itself is chosen based on the type of glue. For example, liquid adhesives are often packaged in plastic bottles, while solid glues like glue sticks are encased in plastic tubes. 9. Environmental and sustainability considerations. In recent years, the glue manufacturing industry has been moving toward more eco-friendly processes. This includes using renewable resources, reducing the carbon footprint, and finding ways to reduce the use of toxic chemicals and synthetic adhesives. Some companies are developing biodegradable and non-toxic glues, such as plant-based adhesives, which are more environmentally friendly than petroleum-based glues. Waste from the manufacturing process, such as chemical byproducts or leftover raw materials, is often recycled or disposed of through proper environmental management practices. 10. Innovations in glue technology. There is ongoing research into more advanced adhesive technologies, such as smart adhesives that can change properties based on environmental stimuli like heat or light. Bio-based glues. The use of bioengineered or plant-derived materials is growing, with scientists developing glues from things like fungi or bacteria. Heat-resistant and waterproof adhesives. Manufacturers are also creating specialized glues that can withstand extreme temperatures or moisture, making them ideal for construction, automotive, and marine applications. 11. Types of adhesive applications. Different types of glues have specific uses, and the production process can vary depending on the end application. Here are some common glue types and their uses. Industrial adhesives. Construction adhesives. Used in building materials like drywall, flooring, and roofing. They need to be strong and durable to bond heavy materials. Packaging adhesives. Often used in the food and beverage industry. These adhesives must meet specific safety regulations and adhere to various materials like cardboard, plastic, and metal. Automotive adhesives. For car parts like dashboards, bumpers, and trim. These adhesives must withstand heat, moisture, and vibration. Consumer adhesives. School glue. Common in classrooms and homes, it's typically water-based and safe for children. These glues are usually made from PVA polyvinyl acetate, and are easy to clean. Super glue cyanoacrylate, fast drying and very strong. Super glue is commonly used for bonding small objects such as ceramics, metal, and plastic. Hot glue. Used in craft projects. Hot glue is applied with a hot glue gun and is perfect for quick bonds on materials like fabric, wood, and plastic. Medical adhesives. Skin adhesives. Used in medical applications like wound closure. These are special, non-toxic adhesives that are designed to bond tissue without damaging skin. Surgical adhesives. Some surgical procedures use adhesives instead of stitches for quicker healing and less scarring. 12. New trends and innovations in adhesive technology. The adhesive industry has been evolving, with new research and innovations aimed at improving performance, environmental impact, and versatility. Recyclable and eco-friendly adhesives. As sustainability becomes more important, adhesive manufacturers are developing more eco-friendly options. These glues are made with renewable resources and have a lower environmental footprint. Water-based adhesives. These adhesives are made from plant materials and are safer for the environment. Compared to traditional solvent-based adhesives, these types of glues are particularly important in industries where disposal or recyclability is a concern. Smart adhesives. A relatively new category of adhesives. Smart adhesives can respond to external factors like heat, light, or pressure. For example, adhesives that can change their properties based on temperature or humidity are being explored for use in smart packaging or medical devices. Conductive adhesives. These adhesives are designed to conduct electricity and are used in electronics. They allow for the bonding of electronic components without the need for traditional soldering, offering a flexible, efficient way to assemble products like circuit boards. High-performance adhesives. These are used in extreme environments. For example, aerospace adhesives need to withstand very high temperatures and pressures. Advances in polymer chemistry have led to adhesives that can endure such conditions without losing their effectiveness. Fungal and bio-based adhesives. Some companies are researching adhesives made from fungi or bacteria. Mycelium, the root-like structure of mushrooms, is being studied for its ability to bond materials in a sustainable, biodegradable way. Other bio-based adhesives are derived from proteins or cellulose extracted from plants, making them safer for both humans and the environment. 13. Adhesive failure and troubleshooting. Sometimes glue doesn't bond as expected, and adhesive failure can occur. Understanding why adhesive failure happens is crucial for improving manufacturing processes and product reliability. Poor surface preparation. Adhesives require clean surfaces to bond effectively. Any dirt, oil, or moisture can reduce the glue's effectiveness. It's essential to prepare surfaces properly before applying glue. Incompatible materials. Some materials don't bond well with certain types of adhesives. For example, silicone-based adhesives might not adhere well to materials like polypropylene or polyethylene. Testing compatibility is crucial for industrial uses. Temperature or humidity issues. If the adhesive is used outside its recommended temperature range, or in a very humid environment, it may not dry or cure properly. Adhesives are often formulated with specific environmental conditions in mind. Improper curing. Many adhesives need to cure over time or require heat or UV light to fully set. Inadequate curing can lead to weak bonds and premature failure. Excessive adhesive use. Applying too much adhesive can result in poor bond formation and excess glue seeping out when pressure is applied. It's important to apply just enough for a solid bond. 14. Historical context. The evolution of adhesives. The history of adhesives dates back thousands of years, and its evolution has significantly shaped human society. Ancient adhesives. The first adhesives were likely natural substances like tree sap, plant resins, and animal glues. Ancient Egyptians are believed to have used glues made from natural materials to bind wooden objects. Ancient Romans. The Romans were known for their use of adhesives in building and for binding their scrolls. They used mixtures of resins, waxes, and fats. Middle Ages. The development of animal-based glues like hide glue flourished during the medieval period, especially in the creation of books, furniture, and musical instruments. Industrial Revolution. The development of synthetic adhesives began during the Industrial Revolution, particularly with the discovery of rubber-based adhesives, which were used for packaging and labeling. 20th century. With the advent of plastics and synthetic polymers, new types of adhesives like epoxy, cyanoacrylate, and pressure-sensitive adhesives were created. These innovations enabled the construction of everything from electronics to airplanes. Late 20th and 21st centuries. Today, the focus is on developing more specialized adhesives with unique properties for various industries, such as automotive, medical, aerospace, and electronics. 15. Future of glue manufacturing. The future of glue production is focused on creating more durable, eco-friendly, and versatile adhesives that can perform under extreme conditions, as well as reducing the environmental impact of the manufacturing process. Nanotechnology. Scientists are exploring the potential of nanotechnology to develop ultra-strong adhesives. By manipulating materials at the molecular level, glues could become even more durable and versatile, offering new possibilities for industries like electronics and medicine. Self-healing adhesives. Researchers are also investigating adhesives that can self-heal. This means that if the glue is damaged or broken, it can repair itself, much like how certain materials in nature can heal when injured. 3D printing. The rise of 3D printing has opened up new possibilities for adhesive use. Special adhesives are being developed to support the creation of printed objects and to help bond 3D printed materials together. Advanced biodegradable adhesives. The demand for biodegradable and compostable adhesives will likely continue to grow. Future advancements in bio-based adhesive materials could lead to fully biodegradable products that offer the same performance as traditional adhesives. 16. Niche applications of adhesives. While most people think of glue in terms of everyday uses like craft projects or home repairs, adhesives are essential to many specialized and high-tech industries. Here are some niche applications. Aerospace. In the aerospace industry, adhesives are often used for bonding parts that must withstand extreme temperatures, vibration, and weight constraints. High-performance adhesives like epoxies or cyanoacrylate are crucial for parts like fuselage panels, wing structures, and even interior components such as cabin fixtures. The use of lightweight composite materials in modern aircraft, such as carbon fiber, has made adhesives even more critical for ensuring structural integrity, without adding unnecessary weight. Electronics. Adhesives are essential in electronics for assembling circuit boards, sensors, and display screens. Conductive adhesives are used to replace solder in assembling electronic components, allowing for more flexible designs and eliminating the need for heat during assembly. With the rise of flexible electronics such as bendable screens and wearable devices, adhesives are increasingly required to be flexible, durable, and resistant to heat or moisture. Medical devices. Medical adhesives have unique requirements due to their interaction with human skin or internal body tissues. For example, bioadhesives are used to bond tissues during surgeries and are designed to be biocompatible and able to degrade safely over time. Textile industry. In textile manufacturing, adhesives are used in non-woven fabric bonding, garment construction, and even for fabric prints. Certain adhesives are formulated to be flexible, durable, and resistant to washing or friction. Water-based adhesives are gaining popularity in this industry because they're non-toxic and work well with the diverse range of fabrics used in clothing and upholstery. Automotive industry. In addition to structural uses in car manufacturing, like bonding panels and interior components, adhesives in the automotive industry help with soundproofing, insulation, and improving vehicle fuel efficiency by reducing the weight of fasteners and welds. Windshield bonding. Adhesives that are designed to hold windshields and windows in place are crucial to a vehicle's structural integrity. These adhesives must remain strong even under harsh weather conditions. 17. Challenges in glue production and application. Despite the great strides made in adhesive technology, there are several challenges in glue production and application. Environmental impact. The production of traditional adhesives, especially those using petroleum-based polymers, can have a significant environmental footprint, both in terms of carbon emissions and waste generation. While some adhesives are biodegradable, others can take hundreds of years to break down, contributing to plastic waste. Sustainable sourcing of materials. There is a growing push for using renewable materials and adhesives, such as plant-based resins, to reduce the environmental impact of production. Reducing harmful chemicals. Many glues contain solvents and other volatile organic compounds, VOCs, that can be harmful to both the environment and human health. Reducing or eliminating VOCs in adhesives is a major goal for manufacturers today. The ability of an adhesive to maintain its bond strength in these environments is a critical factor in selecting the right glue for a particular application. The chemical degradation of adhesives over time, especially in outdoor or industrial environments, remains a challenge. As adhesives age, they may become brittle, lose their bond strength, or react negatively to their adhesion to difficult surfaces. Some materials like certain plastics, metals, or silicones are notoriously difficult to bond with adhesives. This is because they have low surface energy or are chemically inert. Surface treatment techniques like priming, etching, or plasma treatment are used to improve adhesive bonding to these materials, but this can add extra steps and costs in manufacturing. Automated adhesive application systems are commonly used in manufacturing, but even these systems face challenges in ensuring consistent and precise application. 18. 3D printed glues can be designed for particular materials and performance requirements, allowing for highly specialized adhesives that would be difficult or impossible to create using traditional methods. Additionally, 3D printing technology is also being used to print products that require specific adhesive formulations, such as flexible electronics or wearable medical devices. Nanotechnology. Nanotechnology is being applied to create adhesives with improved properties. Nanofillers such as carbon nanotubes or silica particles can be added to glues to enhance their strength, flexibility, or conductivity. Nanocoatings applied to adhesive surfaces can also improve their resistance to corrosion or wear and tear, making them ideal for high-performance applications like aerospace or automotive parts. Microencapsulation. Microencapsulation is a technique where the adhesive is sealed within small capsules that only release their bonding properties when triggered by heat, pressure, or moisture. This technology allows for self-healing adhesives, which can repair themselves when exposed to damage or stress. Smart manufacturing. The adhesive industry is also benefiting from Industry 4.0 technologies, including the use of sensors, real-time data collection, and AI to improve manufacturing processes. Smart systems can detect variations in raw material quality, monitor production efficiency, and adjust conditions on the fly to ensure the highest quality adhesive products. Hot melt adhesive systems. These systems are used in industries like packaging and labeling. In hot melt adhesives, solid glue is heated to a molten state and applied quickly to bond materials together. This process is fast, efficient, and cost-effective, but the adhesive's cooling rate and viscosity must be precisely controlled to avoid mistakes in application. 19. Some key regulatory considerations include safety regulations. Many adhesives contain hazardous chemicals that require strict handling, storage, and labeling. For example, adhesives with solvents, for example, acetone, toluene, xylene may be regulated to ensure that they are not harmful to workers or consumers. FDA approval. Medical adhesives used in procedures such as wound closure or surgical implants must be approved by regulatory agencies like the FDA, Food and Drug Administration. In the United States, this ensures that the adhesives are safe and effective for medical use. VOC emissions. Solvent-based adhesives can emit volatile organic compounds, VOCs, into the atmosphere, contributing to air pollution and health risks. Many countries have set limits on the amount of VOCs that adhesives can emit, forcing manufacturers to develop low VOC or solvent-free alternatives. Environmental certifications. Adhesive manufacturers are increasingly required to meet sustainability certifications like ISO 14001 or Green Seal, which set standards for environmental performance and waste management in manufacturing. These certifications help ensure that adhesive products are safe for both people and the planet. 20. Asia-Pacific is one of the fastest-growing regions for adhesive production, driven by booming manufacturing industries, particularly in China and India. Additionally, The expansion of the electronics and automotive sectors in Asia is fueling adhesive demand. Emerging markets in Africa and South America are also contributing to the growing demand for adhesives, particularly in packaging, construction, and manufacturing.